As a continuation, I am going to draw another diagram that represents what happens when the battery is connected. Now there is no battery connection here, so it is just that way. Now let's see what happens. If we have a voltmeter again, alright, and this time around we have the electrodes as usual. I'm trying to make my diagram look big so that my explanation will be clear. Alright, so I have this. Okay, I have to connect certain things here. Cell, okay, and then maybe the key, okay, and maybe this key is connected to rheostats. Rheostats for altering the value of current entering into the system, and we have that all back to this. If this is positive, definitely this should be negative. And remember, I call this the cathode. The cathode plate or rod. This is the anode, right? Good. So if we have this, we can now explain what happens. We can now explain what happens. Okay? This symbol you are looking at represents liquids, electrolytes. Maybe this time around it could be hydrochloric acid, it could be tetraoxosulfuric acid, it could be just normal salt. So far it can conduct. But my interest is not the type of solution it is. My interest is, an electrolyte. That's my interest. So what happens? Look at this. Let's assume that the key is open. Let's assume that the key, the switch, this is the cell, this is the key, and this is the rheostat, variable resistor, okay? The cell supplies energy to the system. The key regulates open, is an open, or rather it is an on and off device that regulates the current flow. If you want the current to flow, you put it on or you switch it on. If you want it to stop, you turn it off. That's what the key does. The rheostat regulates the amount of current flowing, gives you some value, not big, not too small. That's what it does to avoid affecting the system. And the two rods I have already explained represent the cathode plates and then the anode plates. Now, if we understand all that, now look at this. Now, the key or the switch is open. When it is open, there is no current flow in the system. There is no current flow at all. So what happens? What happens to the molecules of the liquid? Or to the particles of the liquid? What happens? They continue to move in a random way. They continue to move randomly because there is no defined order. And since there is no current flowing, there won't be any defined order in this. That's the cause of the random movement. Alright. That is it. If you understand that when the key is open, the particles of the liquid or the molecules of the liquid move randomly, darting about. They dart about because there is no orderliness. But guess what? Immediately the key closes and then current begins to flow. Oh my goodness. Current begins to flow. Can you imagine that? Current begins to flow. Look at my arrow. Current begins to flow into the system. Look at it. And flows out from here. You know what happens? These particles that were busy moving up and down randomly will organize themselves. Quickly organize themselves. Because this is a positive pole. This is a positive plate. Alright? And this is a negative plate. Take notes. As soon as current begins to flow, they become charged. They become charged because they are non-ionic. They are ions. They become charged. That's the meaning of charged particles. And the charged particles are referred to ions. All right? They become charged because there is what? Current flow into the system. Their random movement stops immediately. Their random movement stops immediately, and they begin to align themselves according to their various charge orientation. Those that are positive. Oh, I love this. Those particles that are positive, we drift towards the cathode, because you know positive particles, positive attract negative. Because the cathode is negatively charged, it will attract positive particles around itself. So what will be here is plus, tending towards this, plus particles, positively charged particles, tend towards this. Because the cathode is negatively charged, there is an attraction between negatively charged plates and positively charged particles known as the ions. That's what happens at this point. Of course, you know what will happen next. What will happen next is, because the positively charged ones have drifted towards the cathode, of course, correspondingly, the negatively charged ones, charged particles, will drift towards the anode. The negatively charged particles will now drift towards the anode. That is exactly what happened. And we call this electrolysis dynamics, or dynamics of charged particles in electrolysis. That's what it means. Look at it, very beautiful, interesting to learn. Don't mind my word. Come on, I love this concept. Once current is maintained and flows through the system, the particles become charged. Take it again. Once current is made to flow through the system, the particles become charged. And because of the fact we have positively charged plates and then negatively charged plates, the positively charged particles will drift towards the negatively charged plates, because positive and negative attract each other. Know that. The same thing that happens here. Correspondingly, because this plate is positively charged, negatively charged particles will drift to this positively charged plate. As a result of positive will always attract negative. That's what happens here. And we call this ionic process in electrolysis. That is it. Very simple. All right, come on. I'm going to sign up once again. I'm done. If you have understood this, it's okay. It is called electrolytic charged particles, or ionic process in electrolysis. I sign out once again. But before I go, please, I hope you have not forgotten. Subscribe. Come on, subscribe. Thumbs up. Put on the bell button for constant notification, and then belongs to this family. You need this. If you don't need it, send it to somebody who needs it. Thank you.